Volume of solids. This is my second recorded lesson on volume of solids. Solids formed by revolving a region bounded by two curves. When a region bounded by two curves in the closed interval AB is revolved around the x-axis, it forms a solid whose cross-section at x form an annular ring. And the volume is equal to this. So this plane region here, which is bounded by two functions, okay, f of x and g of x, we will revolve it around the x-axis. And when you do that, okay, so you will form a three-dimensional object, a solid, which is kind of hollow, okay, hollow in the middle. And this is how we compute for the volume of that solid. It is equal to pi times the integral of the square of f of x. Okay, so the function that is above the plane region minus the square of g of x, which is the function that bound the region below the region, dx from a to b. Okay, and so when you revolve it around the x-axis, the cross-section of this solid is going to be an annular ring, okay? Something like that, something like this. You know, I am not yet an expert in using GeoGebra. I had been using this for 2 years, 2 or more years, but I rarely get I don't often teach integral calculus, and I had only a few occasions, few opportunities to talk about solids, even when I am teaching integral calculus. That's why it is really something to speak nicely about distance education, online teaching, because here I'm able to reach this topic. Okay, so in the old days when I talk about the solids of revolution, I'm using an old software to show the solid. And so this is how the solid of revolution might look like, okay? The cross-section of your solid forms an annular ring. Okay, so let us solve a problem. Find the volume of the solid when the region bounded by y is equal to x squared and y is equal to square root of x is revolved around the x-axis. Well, what is the interval of this integration? Well, we must look for their points of intersection. Where will x squared intersect the square root of x? And the solution to this equation is this: x is equal to 0 or x is equal to 1. And so that is the boundary of our integration, or the interval of our integration. It's from 0 to 1. Set up the integral. So this is kind of tricky. Okay, so you must see what is the function that is above the bounded region, and what is the function that is below the plane region. And so we need some visualization. Okay, so we must see this plane region in your rectangular coordinate system. And this is it, okay? The function that is above the plane region is f of x is equal to square root of x. And the function that is below the plane region is the quadratic function. Okay? So this is how we set up the integral. The volume is going to be pi times the integral of f of x squared minus g of x squared dx from 0 to 1. Well, it's easy to get the antiderivative of that. That is just the integral of x, so it's going to be 1/2 times x squared minus the antiderivative of x to the 4th dx is x to the 5th over 5. and then the whole thing evaluated from 0 to 1, and it is equal to this, 3 pi over 10 cubic units.